All right, here we go. So on your Chromebooks, you guys have the function you guys just graphed. Now what I'm going to go over, Gomez, is related to those behavior questions that you couldn't do. Notice the function goes up, it comes up, then goes down, then comes back up, and it goes up to infinity. It doesn't stop. Go ahead on your screen with your index finger, go over the graph and make sure you can see ordered pairs. Go and do that for me. Just practice. With your index finger on your screen, go down and go up on with your index finger and make sure you can see the ordered pairs. Thank you, Arce. Thanks for the observation. That's wonderful. So look at the x and y's. Go ahead and do that. Right, anywhere you want. And what I want you to understand and get in your mind is that every ordered pair, is everyone able to do what I'm doing? Every ordered pair is, finish it off, Gomez. What is this in relation to the equation, this equation here? What are these ordered pairs? They all satisfy. Every single x, y ordered pair satisfies this function. How many ordered pairs are there in this graph? Infinite. It goes, look at, it goes to positive infinity, and coming down over here, it goes to negative infinity down here. That's what we call behavior. It behaves a certain way. The way the function looks will determine, Perez, will determine its behavior. You have different children, they'll behave differently, right? If you have any child, you've done any child care, depending on the personality, their behavior is a function of their personality. The behavior of a function depends on these exponents. Look at this, exponents to the 5th power. The coefficient here is 3, the number in front of that variable. What's the coefficient of the negative x to the 4th? What would be the coefficient here? Anybody? 1. -1. See, all these coefficients and all these exponents determines the behavior of the function. Okay? It determines the behavior. Now, I'm going to pass out a piece of graph paper. But before I do that, on your note paper, or actually on your warm-up paper, even though you don't have any warm-up paper, get a piece of paper out. Yeah, better yet, let me pass out the. Hold on. Let me pass out the note guide. Don't. Just write the function f of x equals 3x to the 5th minus x to the 4th minus 6x plus 10. Go ahead and write that function on the back, just on the top. You got yours from first period? Or I just gave you one. So not on the front, but on the back, go ahead and write f of x equals 3x to the 5th minus x to the 4th minus 6x plus 10. In other words, go ahead and write the function down that we just graphed. Right, Fuentes? Yeah. Did I give you the handout? Yeah. Okay. Do you need a pen? Yeah. You're the man. On top of my laptop card, go and grab one. It's too far? All right, let's do it. Let's review what I went over 2 days ago before we took the day off, the break. That highest exponent right there is called a degree. That's the degree. So this is a polynomial function of degree 5. Also, this x, even though you don't see an exponent on the x, it's automatically raised to the 1st power. Go ahead and put that there for me. So again, this function is on the back of the paper. You're writing this on the back, not on the front. Go ahead and put an arrow at that 3. Let's call that the leading coefficient. This is a review of what we did 2 days ago. All this, the degree, the coefficients, the lead coefficient, all that determines the behavior, the way the function behaves. Now, on that same side, okay, on the space underneath now, on the same side of this paper I just passed out, you're going to go ahead and create a table that looks like this. Give me 4 columns and 6 rows. Take up like most of the paper. 4 columns, 6 rows, and we're going to be done. This is all of our notes today, and we're done. 4 columns, 6 rows, take up most of the paper in the back. Pass this to Miss Gonzalez. You don't need a ruler. It's going to be okay. It'll be okay, trust me. It's going to be okay. So we know what degree is. The degree is the highest exponent of any function. We just went over that. So this would be a polynomial of degree 5. Now, there's special names for certain types of degrees. What would a polynomial function look like if it had degree 0? Go to put this on your notes. So on the first column, first cell, put 0. A degree 0 would be a constant function. Go and write constant. A constant function. Huh? Sure. Want to say something?
Hi.
That was Mr. Odyssey, YouTube world. Just wanted to greet you. What would the form look like of a constant function? Check this out. F of x is just any number a. Let's call the number a. Not 9. Forgive me if my a's look like 9s. That's an a. So any number. A function that's just a number by itself would be called a constant function. Let me give you an example. Watch. F of x is more. What's your favorite number? That's a constant function. Notice there's no x. No x's at all. Just a number. What would that look like? That would be kind of funky. We're going to get into that later. Let's take my pass. Let's take my pass. How about a function that's of degree 1? Check this out. That looks like a 7, doesn't it? Shame on me. Shame on me. Shame, shame, shame. I know, you're right. A function of degree 1 would be a linear function. Write this with me. Think y equals mx plus b. Watch this. F of x equals ax plus b, for instance. What exponent is that x raised to? Somebody, please, before I cry. It's raised to the first. If it's not written, it's raised to the first power. Therefore, it's a linear. It forms a line. This is what we did 2 weeks ago when we graphed lines. Mx plus b. X is raised to the first power, so it became a line. So let me give you an example. F of x equals, I'm gonna write it in mx plus b form. Fuentes, what's your favorite number? 4x plus 3. Notice how x is raised to the first power, therefore that function's linear. All right. What if it's raised, what if we have a degree 2? Math 2 students who are veterans of my Math 2, someone besides Adam Gomez, if x is raised to the second power, what are those equations called that form parabolas, that open down or open up? It starts with a Q. Quadratic. Perez, you're the man. So degree 2 is quadratic. We're talking a quadratic function. Think of parabolas in Math 2. Let me give you an example. F of x equals ax squared dot, dot, dot. Now, when I put dot, 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 that just means other terms. Keep going on. As long as you want, that's fine. Here's an example. Obviously, what's your favorite number?
2.
Watch this. F of x equals 2x squared plus 4x plus 3. The exponent is to the second power, therefore we call it quadratic. It's a degree 2 polynomial. It's called quadratic. All right, you guys ready? Yeah. No, I think it's cool. It's cool to have privileges that you don't. I could rub it in your... Never mind. Just kidding. 3. I know. If something's raised to the third power, we say it's not something squared, but something what's the word? Cubed. So the third power, or degree 3, would be a cubic function. Cubic. F of x equals ax to the third dot dot dot. The highest exponent is 3 now. So f of x equals, Paragon, what's your favorite number? 5x cubed, look at this. 5x cubed plus 4x squared plus 3. How about that? Just made it up at the top of my head. That would be a cubic function. Last but not least. Please. Thank you, Doug. 4. Last but not least. Let's do it before the bell rings. Instead of cubic, quartic now. Quartic. Right. 4th dimension. You're right. Quartic. F of x is ax to the 4th dot dot dot. Ibarra, what's your favorite number? 11x to the 4th plus 5x to the 3rd plus 3. Quartic function. Computers back in their slots. Do not lose this paper. I put a 3-ring hole punch on it so you can put in your binder. I'll see you guys tomorrow. I'm coming around to give you a second stamp if you've been a good boy or a good girl today. Stamp sheets out without a doubt coming around.